This is our first lesson in the Flux course. By now you've probably seen the intro and understood what Flux is all about, but let's recap. Flux is all about managing your Kubernetes state in a declarative way. So instead of doing kubectl apply, helm install, and changing this way your Kubernetes state, it's much better to do it in a declarative way. With the Flux GitOps way, you simply push YAML files to a Git repository. Flux will pick up on those files and manage the state of Kubernetes according to the YAML files that you push to a Git repository. And in this lesson, the first lesson in our Flux course, we're going to focus on how to install Flux on your Kubernetes cluster. As usual, this entire lesson is available online. I'll place a link in the description. Every step that we take here, you have a step-by-step guide at academeez.com, so check out the link in the description. So to TLDR this lesson, to install Flux in a cluster involves the following steps that we will show in this lesson. First, we'll have to install a CLI tool called Flux CLI. This tool allows us to communicate from our computer to a Flux running on our cluster, as well as also install and bootstrap Flux on our cluster. We'll also have to open our repository to store our YAML files. As a reminder, Flux will read content from a repository that we will open, and based on the YAML files that Flux is grabbing from that repository, Flux will manage the state of Kubernetes according to those YAML files. So we'll have to open our repository. In this lesson, we'll open a GitHub repository for Flux to read our YAML files from that repository. We'll have to create a personal access token like a password for Flux to read content from a repository. Flux need to access the GitHub repository that we'll open to store YAML files. Flux need to read the content from that GitHub repository. In order to read the content, Flux will need to supply Flux with the correct privileges, the correct access token to read the content from that GitHub repository. So we will have to create something called personal access token and give Flux that personal access token so it can read the content from the GitHub repository that we opened. We'll have to then bootstrap Flux, and it's relatively simple. It's just a command that we have to run using the Flux CLI. So that command is flux bootstrap to install Flux on our cluster. And each and one of those steps we are going to show in this lesson. So examine those steps and try to do it also yourself. Try to follow the step, follow this lesson, and install Flux on your cluster as we go along in this video. Before we start install Flux on our cluster, let's make sure that our cluster meets the necessary prerequisites before we continue. So in order to complete this lesson and install Flux on your cluster, obviously you need to make sure you have a Kubernetes cluster, and that cluster version needs to be greater, server version needs to be greater than 1.26. We highly recommend to use a managed Kubernetes cluster from one of the cloud providers. So you can use, for example, GCP or AWS or Azure. In this lesson, we are using a managed Kubernetes cluster from GCP, which is EKS, a managed Kubernetes cluster service in GCP. And you have to make sure that the server version is greater than 1.26. You have to make sure you have kubectl installed and that you can communicate using kubectl with the cluster with your cluster. So the best way that you can check if you're meeting all the prerequisites is just going to the terminal and just typing kubectl version to check out your client server version. You need to make sure that your server version, you will see server version if your kubectl can communicate with your server. So make sure you see a server version and make sure that the major is 1 and the minor is greater than 26. So mine is 27. So that's a good way that you can make sure that you meet the prerequisites. So open the terminal, run kubectl version, and make sure that your server version meets the required demands for Flux. Our first step of installing Flux is to install Flux CLI on our computer. Now, the Flux CLI is something that enables us to communicate with Flux running on our cluster, as well as also run, for example, installation command, bootstrap, updating Flux. So you can install the Flux CLI. I'll place a link in the description for the documentation of Flux and how to install the Flux CLI. In our case, we are going to use Homebrew to install Flux CLI. So the command is brew install FluxCD tab Flux. I'll place the link in the description to how to install the Flux CLI. So we'll take this link and we'll copy it to our terminal. Give it a few seconds and it will install the Flux CLI. So the installation is now finished, and if everything went successfully, you should be able to go to your terminal and type flux -- version. And at the time of this recording, we are using Flux version 2.2.2. This is the version that the Flux CLI version that is installed on my computer, and we'll use the Flux CLI to help us with various commands as well as help us install Flux in our cluster. After we install the Flux CLI, let's go over the popular commands of Flux CLI that you will most often use. So some of the commands, and you can, by the way, examine all the commands by going to your terminal and typing flux -- help. You get a list here of all the commands that Flux CLI gives you. So let's go over some of the popular ones. So first of all, you have the flux bootstrap command. So this is the flux bootstrap command, and we use this command to install Flux in our cluster, as well as update Flux, as well as install extra components if we want other components that Flux provide. So we can use this command, the bootstrap command. We'll see this command in a minute when we use this command to install Flux in our cluster. Another command that we have, and we'll also examine this command in a minute, is the flux check command. So this is the flux check command. We use this command to verify that our cluster meets the required demands, and you can also use this command to verify that Flux installation is okay. So if you want to read about this command, you can do flux check -- help and see that this command can be run with the pre-flag before Flux is installed to check that your cluster meets the necessary demands, and also you can run it without the pre-flag, which will check Flux installation if everything is installed correctly. Another command that I often use is the flux create. So we'll talk about in future lesson about the different controllers that Flux provide, but basically when you install Flux, Flux will run pods, Flux controllers that will watch for certain custom resources that Flux provides. And when they see those resources, they perform some sort of action, whether it's syncing your Kubernetes state or doing something else. And we'll talk further about those things, but Flux Create helps you create those custom resources. So for example, I can go to Flux Create -- help, and I'll see here a few examples of the resources that Flux Create can help you create. For example, one of the popular resources, custom resources that Flux provide, is a customization resource, and we can use Flux Create customization to see an example of creating that customization resource. So, for example, I can copy one of the commands. And usually when I use those commands, I usually don't run those commands directly. Rather, I'm adding a flag of -- export. And this flag will pretty much, it's like dry run. It pretty much will do nothing but print the YAML files to the console. And then I can take this YAML file and then I commit it to the Git repository. Because usually when you use Flux, you want things to be done declaratively by pushing YAML files to your Git repository and then letting Flux grab those files from the Git repository. You don't want to run commands directly. This is the exact thing that we are trying to avoid. Avoid running kubectl apply, avoid helm install, and let things run declaratively. So usually I add a -- export flag so I can commit those files to my repository. So this is the Flux Create. We can use it to create those Flux custom resources that we will learn about in future lessons. We'll also have Flux Reconcile. Now Flux Reconcile, basically Flux needs to manage the state of your cluster. And basically when you run Flux Reconcile, you're saying Flux, can you verify that the state in my Kubernetes cluster meets the YAML file that you currently hold? So basically it means that Flux will synchronize the state of your cluster according to your YAML files. And basically Flux does that automatically, but if you don't want to wait, you can run Flux Reconcile, and then it will run those changes in your cluster right away, instead of you need to wait for Flux to grab all those files and syncing it automatically. So this is another popular command that you will use. And in general, to inspect all the commands, you can do flux -- help, and then you can drill down to those commands and see the -- help and see those examples of those commands. So Flux CLI is a really handy tool, not only to install Flux on your cluster, but also to help you manage, create resources, and do other cool stuff with Flux. One of the commands that we have in the Flux CLI is a command called flux check that can verify if our cluster is ready to have Flux installed on it. So let's go to the terminal and type a flux check -- pre we add this flag before we install Flux, and after we install Flux, if we omit this flag, we have Flux check will verify that Flux is installed correctly. But before you install Flux, you add the ---- pre-flag to check that our cluster is ready to have Flux installed on it. And we see that the prerequisite checks have passed, so our cluster is good to go with the Flux installation. One of the things that we need to prepare before we can install Flux on our cluster is to prepare a repository. In this lesson, we will work with a GitHub repository. So we'll open a GitHub repository for Flux and give Flux permission to read content from that GitHub repository. And I want to check a diagram that is posted. I'll post it in the links, but it's in the Flux documentation. And it's not important for me that you understand now the diagram, because we'll go over the diagram in future lesson. But there is one part that I want you to understand, and this is the source control and the sections, those icons on the right. So Flux is installing, when you bootstrap Flux, Flux will install controllers as pods in your cluster. One of those pods, one of those controllers is called source controller. And this source controller is able to read content from a GitHub repository or a GitLab repository or a Helm repository or a bucket or an OCI repository. So this source controller can read content from different sources. And as you see, he delivers that information to other Flux controllers, like the customized controller or the Helm controller. We'll go over those other controller in a future lesson. But this is the entrance of the sources of data that other controller will examine. So they'll grab the data from the source controller. So you have to at least have a Git repository to store Flux information in. Later, you'll probably add Helm repository and more sources to the source controller. But for now, we'll work with a GitHub repository and we'll tell Flux to grab content from that GitHub repository. So this is the section here of the source controller, and the three icons here refer to the sources from where Flux can grab content and pass that content along to other controllers that Flux has. So Flux will have to read content from a Git repository. So it's not only a Git repository, we'll also set the source controller to read content from a Git repository and a branch. So Flux will read content of a branch in a Git repository. In this lesson, as I mentioned, we'll tell Flux to read content from a GitHub repository. Later in this course, we'll also add Helm repositories to the source controller, and we'll work with that as well. So what we will tell Flux is to read content from a GitHub repository, track a single branch, will track the main branch, and will tell the Flux that every X amount of time, in our case it will be every 1 minute, we'll tell him to synchronize from that Git repository, meaning grab the new content. If something is pushed to main, every minute try to pull changes from the main branch to grab new content for the other controllers, for the customized controller or for the Helm control. So every 1 minute, the source controller will try to grab new data from our Git repository. And this allows us to commit our Flux resources. We're going to push that to that Git repository. So what it means that we can push new YAML files, new Flux resources to that Git repository, and every minute Flux will grab the new content and will pass those new resources to other controllers that might be listening and watching for those resources. So I can push those YAML files to the Git repository, and this allows me to make every state management in my cluster declarative by pushing YAML files to my GitHub repository and have Flux track that GitHub repository. Then it means that every time that I want to make change to my cluster, I simply push the YAML files, the proper YAML files that describe the change in my cluster, I simply push it to the Git repository. So this is how we'll work with Flux. We'll open that GitHub repository, push new files, and Flux will manage the state of our cluster. And in this course, we will tell Flux to track a single repository, but it's not always the case. You can have Flux track more than a single repository, which might be handy if you have more than if you're managing large teams, then you can open multiple repository. You can open repository for each team and have Flux read from different sources from different repositories. So it's not necessarily a single repository, but in the simple to medium cases, single repository will suffice, but you have different ways to arrange those repositories, and you can open a distributed repositories for each team. So to allow Flux to read content from a GitHub repository, we have to give Flux the proper permissions. So we have to create an access token for Flux and give that access token permissions so Flux can read content from our GitHub repository. So we know that Flux needs to read content from a Git repository. In this lesson, we will work with GitHub. So let's open a GitHub repository for Flux to read the content from. So I'll go to the browser, open github.com/new and create a new repository. I'll call this repository academeez kubernetes Flux. And this is the FluxCD course of academeez. The entire course will work with this repository. So everything will be public, and this repository, this is a single repository for the entire Flux course. So I'll place the link for this public repository in the description of the video. So it's a public repository. Let's add a README file. Let's license it as MIT, open source, and let's create our repository. So we'll later add, so this is our repository. I'll publish the link in the description, and we'll give Flux permission to read content from this repository. Now that we created a GitHub repository for Flux, let's give Flux permission to read content from that GitHub repository. And we will give those permission to Flux by creating something called a personal access token. A personal access token is like a password for your GitHub account, but this password can only be used in the GitHub APIs. And we can provide and we can create that personal access token, provide it to Flux, and then Flux can use that token to read content from the GitHub repository that we just created. Now there are two types of personal access token in GitHub. One is called Classic, this is the older one, and one is called Fine Grained, which is the newer one. Now the Fine Grained is a bit better because you have more power in the limitation of the token, meaning you can limit the token to only access the repository you want. And this is perfect for our use case because one of our focuses is security, and the rule of security is to give Flux that token, but give that token minimum privileges. So Flux doesn't have endless power, but has limited power and only to the repository that we just created. So that token cannot be abused to affect more repository. So we need to create a token with limited privileges as much as possible. This is why we are going to create the Fine Grained token. So we can set the privileges to one repository. And the Fine Grained, as mentioned, can be limited only to the repository that we want. In our case, we have a single repository, so we will limit that token to that single repository. And when we create that personal access token, we need to give Flux that token. The way we do it is by setting an environment variable called GitHub token. And then during the Flux bootstrap command, Flux will grab that environment variable, and then Flux will create a secret in your Kubernetes cluster that holds that token. This way, Flux will have access to that token whenever it needs to read content on the repository. So Flux will take that token, and in order to use it in the future, Flux will create a secret in your cluster that contains that token. Now, that token, as we mentioned, security is important, so we'll have to set an expiration for that token. And it's recommended to set a limited amount of expiration, not an endless token for the end of days, but something that is more limited. In this lesson, we're going to create a token that is valid for 3 months. And this means that we will have to rotate that token. Now, rotating that token means that we'll have to once that token expires, we'll need to change the secret that Flux created with the token. We'll just need to replace that secret with a new value. And as we mentioned, we need to create our personal access token with minimum permission and with limited time. So security is a big aspect here. Let's create a fine-grained access token so Flux can read content from the GitHub repository. We'll keep in mind to allow that access token to only access the GitHub repository that we created, and also we give limited time for that token. So we will go to GitHub and we'll go to github.com settings, personal access token, new, and I'll place the link in the description. And here we can create our token. We'll name our token Academeez Flux course. And we'll set the expiration. Remember, setting the expiration not to an endless, you can add custom and have it expire in endless time, but it's recommended to have limited time for your token and then rotate that token once that time expires. So we'll set it to 90 days and we'll write a description, Flux token for Academeez FluxCD course. Now I'll set to the repository access to only access the single repository that we created. So I'm going to limit it even more, and I'm going to place only select repositories, and select repository, we name the repository Academeez Kubernetes Flux, FluxCD course for Academeez. We'll select the token only for this repository. Now, regarding the permission, we'll give repository permission, and we will allow the Flux to allow the content section, and we'll place this, allow it to read and write content to the repository. And this is pretty much the only privileges that we will give it. The rest, as we said, we try to limit as much as possible. If we don't need to give Flux those permission, we won't give them. So we'll give Flux the minimum permission, but Flux do need to read. And for the first Flux Bootstrap, Flux will also need to push changes to the repository. You'll see after I run Flux Bootstraps that some changes are pushed by Flux. So Flux will need the read and write permission here. And I think that's it. And after this is done, we're going to click the generate token, and the token will be displayed for us, and then we'll copy that token. So let's click generate token and wait for the token to be created. Once you created your token, we need to give Flux that token so Flux can create a secret and hold that token in a secret. And the way we give Flux that token is by setting an environment variable. So I'll go to the terminal and I'll export GitHub token, environment variable called GitHub token in capital letters, equal, and then after the equal sign, I will paste the personal access token that I just created. So paste your token here and save that token in an environment variable called GitHub token. We are almost ready to install Flux in our Kubernetes cluster, and we'll install Flux by using the Flux bootstrap command. So Flux needs to create stuff on our Kubernetes cluster, create resources, create controllers, create pods. So we need to tell Flux and allow Flux to create those resources in our cluster. And there are different ways this can be achieved. And you actually have in the official documentation and installation guide, I'll place the link in the description, where you have instruction how to bootstrap Flux in your cluster, how to install Flux in your cluster. And one way, this is the way that we will do in this lesson, is to use the Flux CLI that we installed earlier and use the Flux bootstrap command. This is what we'll use in this lesson. But if you scroll down, there is also a guide how to bootstrap Flux in your cluster using Terraform. In this lesson, we'll use the Flux CLI, the bootstrap command. And once you run Flux Bootstrap, Flux will create those resources and controllers, but Flux will also push, since everything after you install Flux, everything will be declarative in YAML files and saved in the GitHub repository that we just opened. So Flux will not only create all those resources, but push to the repository that we created the appropriate YAML files that describe what Flux is created. So you see a folder called Flux System with all the stuff that Flux created in our cluster. And Flux Bootstrap will also create a secret that holds the personal access token that we just created. Before we start running the Flux bootstrap command to install Flux in our cluster, I want to talk about multiple cluster support. Flux can manage our cluster, but it can manage more than one cluster. And you place in the GitHub repository that we opened for Flux, we're going to push YAML file configurations for the cluster. But that GitHub repository can hold more than one configuration for one cluster. It can hold configurations for multiple clusters. And I highly recommend, I'll place the link in the description, to read a guide in the Flux documentation that is called Ways of Structuring Your Repository. and it shows different methodologies, different approaches to organize your GitHub repository in terms of files, in terms of multiple clusters. And what we are going to do, in this course, we are going to follow the monorepo kind of structure for our GitHub repository. So let's look at an example how a monorepo repository structure will look like. It also supports more than one cluster. And you'll see as your organization grows, you will have maybe more than one cluster, maybe a cluster for production and a cluster for staging and a cluster for CI. And as your teams grow, you might open dedicated clusters for different teams. So your cluster that you have to manage will grow. So we'll show something that is good for like small to medium size of management of clusters. But as your organization grows, you'll probably want to rethink how to structure your GitHub repository and how to structure the architecture of Flux managing those clusters. But if we look at this file structure, that's how we're going to arrange our GitHub repository. So you have 3 folders: clusters, infrastructure, and apps. So the clusters hold configuration for different clusters. In this example, we have 2 clusters, one for production and one for staging. And the production hold configuration for the production cluster, and the staging holds configuration for the staging cluster. So our GitHub repository will have a folder for clusters to manage more than a single cluster. You also notice that there is an infrastructure folder, and one of the things that I liked about Flux is I noticed that when I open a cluster, there's a lot of repeating stuff that I had to install on each cluster. So before I used Flux, I had to open a cluster, and then I had to install Nginx Ingress Controller. And then I opened another cluster, and I had to do the same installation in the other clusters, because most of the clusters need that Ingress controller. And I noticed that on most of them I installed Cert Manager, and most of them I installed external DNS, and most of them I installed Prometheus. And every time I had to do those installation again and again with each cluster I opened, which became very repetitive and time consuming. So with Flux, one of the things that I like, it's kind of like you're doing base cluster. If you think about inheritance, like a base class, you're doing something like a base cluster that every cluster inherits from. So this is the infrastructure base. You can place packages, stuff to install that's repeating in every cluster, you can place in the base folder. And then when you open a new cluster, it automatically as you bootstrap Flux, it automatically will install all those shared installation in the base. And then there is a specific installation that is only for the production, and specific installation which is only for staging. And then there is a configuration for the apps. The base apps everyone is running, and apps for production, apps for staging. The base is, configuration for apps that's repeating in both of the clusters. So we're going to structure our GitHub repository similar to the monorepo guide in the ways of structuring your repositories guide. And this configuration will help you support not only a single cluster, but multiple cluster. So going back to the slide, often we have to manage more than one cluster. For example, production, staging, continuous integration, those all might take a cluster. As your team grows, you might give a dedicated cluster for a team, and those clusters might have shared infrastructure. This is what we talked about, the base. Those clusters all of them might have Nginx Ingress Controller. And you now can place this entire configuration of the shared infrastructure in one place. And for example, both of them might need an Nginx Ingress Controller. And there are different ways to structuring, and we will focus on the monorepo kind of structuring our GitHub, as we saw in the guide for Flux. I'll place the link for Flux guide to how to manage your repository. So we'll create, this is a similar file structure that we're going to create in our GitHub repository. And it looks something like this, or you will have a clusters, and we'll have a production, staging, and each cluster will open a new folder. Time to install Flux in our cluster. So we're going to run the Flux bootstrap command and create our staging cluster. Now, few things as a reminder, few things that you had to make sure during this lesson is you had to make sure to export an environment variable called GitHub token and place in this environment variable the personal access token that we created. This is one. Another step that you had to do is kubectl version. Make sure your kubectl has good communication with your Kubernetes, that you see a client version and a server version. Make sure to run flux check -- pre, which verifies that your cluster is ready and everything is ready for Flux to be installed, that your cluster meets the required prerequisite for Flux. Now, after this is done, let's go to the documentation. And in the documentation, you have an installation guide, a bootstrap, and inside you have to pick according to the Git repository. In our case, it's GitHub. So select the GitHub here, and you got the Flux bootstrap command. Let's copy this command. We'll change the necessary flags and go over all the flags that's in this command. But let's paste this command here, and let's go walk over this command. So we're Flux bootstrapping. Our repository is located in GitHub. We are using --token auth, meaning we are using a personal access token that is located in the GitHub token environment variable. We need to set details about the repository that we opened. So who is the owner and what is the repository that we opened? So in this, we can go to the repository we opened, our repository, the repository that we opened. This is the user. This is the owner, sorry, and the repository is the last academeez Kubernetes Flux. We need to set Flux to listen to a certain branch. So we'll say we're listening to the main branch, and we need to set the path. Remember that we talked about multiple clusters and the mono repo kind of structure for a GitHub repository. So we said we have a folder for clusters, and then here we'll create a folder for each cluster. And we're creating the staging cluster. So we'll name the path clusters staging. And the personal is if you're using a personal GitHub. If you're using an organization, you need to remove this flag. So we're running the Flux bootstrap command. Let's hope that this command runs successfully. We'll wait a few seconds for this command to run. Great, Flux is installed successfully. All components are healthy. If you want to double check that everything is installed correctly, you can run the Flux check without the -- pre. Now you're actually checking that Flux is running correctly on your clusters. So you can run this command as well. And all checks have passed here as well. So we now have Flux installed in our cluster. So let's examine what happened when we run the Flux bootstrap command. So in the Flux documentation, in the installation guide, Flux installation, there is a nice diagram that describes what happened when we run the Flux bootstrap command. So when we run the Flux bootstrap command, there are things that are installed in our Kubernetes cluster. In the namespace Flux system, there is Flux controllers installed in our Kubernetes cluster under the Flux system namespace. But also there are things that are pushed in our GitHub repository. So everything is reconciled. So what is installed in our Kubernetes cluster will now appear as files in our GitHub repository. So our GitHub repository contains extra files. It contained a clusters folder with not a production but a staging, because the path we chose was cluster staging. So you see a cluster staging, and in it you have a folder called Flux System, and in it you have YAML file describing everything that is installed in our Kubernetes cluster. So let's try to clone the repo and examine what Flux created for us. What did Flux push to our GitHub repo? So I'll go back to my repo, and I'll copy the URL of the repo, and I'll go to the terminal and I'll git clone with the URL. And I'm going to open the folder that's created for us. And I'm going to open it in VS Code. And then we're going to examine all the files that Flux pushed to our GitHub repository. So we opened the GitHub repository with VS Code, and we'll notice that Flux pushed some files. We had only the license and README files, but now we see that Flux created cluster staging, and in the staging created a Flux system. In the Flux system, there are 3 files. One file, which is a customization file, which aggregates a few resources. So it's like grouping those 2 files together. So the main things that Flux created is those 2 files, the components and the sync files. And the components is holding all the components that Flux installed in our cluster. So for example, the first component that we see is a namespace, which is called Flux System. So if we'll go to the terminal, we'll see that if we kubectl get namespaces, we'll see that the Flux System namespaces is added for us. And basically Flux installed all the controllers and resources in the Flux system namespace. So for example, we can kubectl get pods of the namespace Flux system. We'll notice that Flux installed pods, which those are the Flux controllers, and the defaults are for Flux controller, Helm controller, customized controller, notification controller, and source controller. And for now, you will see that we're actually using the source controller and the customized controller. By simply running the Flux bootstrap, we are already using those two controllers. And we're going to have a lesson about each one of those controllers. The things that is more important about what Flux installed, in my opinion, is the second file, the sync file. And in this sync file, there are probably Kubernetes resources that you didn't stumble on. Those are custom resources. So custom resources that Flux create are ending with the API group of FluxCD IO. And in here, the first part is usually the controller that is looking for this resource. So the source here means that the Flux controller that is looking at this is the source controller. And in here, this is what we said when we mentioned the diagram, that the source controller is connecting to the GitHub. So this is the part of the diagram where a source controller is creating a connection to our GitHub repository. So it's creating a connection to our GitHub repository, and it's naming that GitHub repository Flux system. It's in the namespace Flux system, and it has an interval of 1 minute, meaning that it's going to reconcile every 1 minute. Every 1 minute, it's going to grab the latest commits that are pushed to the main branch. And to connect to the GitHub repository, every 1 minute, it's going to connect to the GitHub repository and do a pull. To connect, there is going to use a secret ref in Flux system. And this is the URL of a repository. So we'll notice that every minute, Flux will try to pull from a repository. And we'll also notice that if we do kubectl get secrets in the namespace Flux system, we'll notice that Flux created a secret for us called Flux system. And this is the secret that it's referring to, the secret that is referred to in here, the Flux system, which is the secret that is holding our GitHub personal access token. The other custom resource that Flux created for us is again the FluxCD group, meaning that it's a Flux custom resource, and the first part, customize, means that this resource is significant for the customized controller, the customized controller here. So this is a resource that says, connect to the source ref, to the GitHub repository Flux system, connect to this GitHub repository Flux system. This is the customized controller. When it's creating a customization, it needs a source, the source of data. The source of data is the Git repository that we open. So this is the source reference. And in here, look for the path cluster staging. Look for any relevant YAML files that you can turn to resources. This means that if we add resources to the cluster staging path, even if we are adding resources inside a folder, like Flux did, it created files inside the folder. Everything that we place in the cluster staging, this customized controller will look for that resource, and if it identifies it as a resource, it will create the proper state in Kubernetes cluster. So let's utilize this fact to create a namespace. So what we can do is place in the staging, create a new file. Let's call it namespace.yaml, and let's create a Kubernetes namespace. Kubernetes namespace, and let's name that namespace www. And I'll just place the namespace, and then I'll git add and git commit, and then git push this file, and let's see what happens. I just pushed the file, created a file in the staging folder called namespace, and now let's do a watch kubectl get namespaces. And we'll watch this, and soon enough there will be a new namespace called www. So it might take up to a minute, because remember, the new GitHub repository has an interval of 1 minute, and then there is an interval of 10 minutes for the customization. So it can take up to 10 minutes until this is identified. So let's try. Oh, here it's created. It's created already, the www. So you see that by simply pushing files, YAML files that we place in the staging folder, the customization controller identified it and automatically created those files in our Kubernetes cluster. So we didn't do kubectl apply, we didn't do helm install, we simply added a YAML file, pushed our repository, and then Flux, after an interval of time, caught that we added a new file and then created the namespace for us. So everything is declarative, so everything is cleaner, and now we can use a declarative approach, just push YAML files and Flux will do the rest and create the resource in our Kubernetes cluster. Great job, we managed to install Flux in our cluster, and this is just the first lesson in our Kubernetes Flux course. We will learn how to manage our Kubernetes cluster in a more professional way and manage our cluster using Flux. And during the course, we'll learn how to manage professionally our Kubernetes cluster using the GitHub way, using Flux. We'll learn how to install certain packages, we'll go over important packages that should be included in your Kubernetes, and overall, it is a super important course to upgrade your Kubernetes level. So just to summarize what we've been through in this lesson, we installed Flux, and to install Flux on our cluster, we did the following things. We created a GitHub repository. By the way, if that GitHub repository does not exist, Flux will create that GitHub repository for you. I prefer to create the GitHub repository before running Flux Bootstrap. This way I can limit the personal access token to only allow access to the repository I open, and I can give less privileges to the personal access token. But if you don't have a GitHub repository, Flux will create one for you. And also we created a fine-grained personal access token with minimum permission, minimal expiration date, and learn how to do it securely. We ran Flux Bootstrap to install Flux controllers, resources in our cluster. Flux also pushed in our GitHub repository, pushed YAML file describing everything that is created in our cluster. That's it. Thank you for listening. As a reminder, this entire lesson, if you like reading more than watching video, this entire lesson is available in academeez.com. I'll place the link in the description. There's a step-by-step guide how to install Flux in your cluster. Also, star us on GitHub and like and subscribe if you like our content. That's it. Thank you for listening.